Welcome to Chapter 6, Section 6.1. We're going to be discussing intramuscular and subcutaneous injections. We're going to be looking at several examples of labeled boxes and bottles and getting comfortable reading them, and then also solving for both volume and quantity of drugs in injectable solutions using either our ratio proportion method or the dimensional analysis method. The first thing I want to touch on also is that we're going to be looking at calculating ratio strength, which is a little bit different. Ratio strength means that there are A parts of a pure drug and B parts of a liquid solution. The units indicated in a ratio strength are always going to be grams or milliliters. This is the same unit rule that's used to indicate the percent strengths of medications, which we've already looked at. So for example, a 1% solution could be written as 1/100th, and the units would be 1 gram and then 100 milliliters. Now if you look at the example on the board, we're going to do one together so you can kind of see firsthand. If you open your book to page 149, we're going to look at example 6.1.7 so you can follow along. And as we can see, how many grams of a drug are present in 500 milliliters of a 1/200th solution? So, what we had just talked about, the 1/100th solution would be written as 1 gram per 100 milliliters. So for this example, it's a 1/200, it's going to be 1 gram per 200 milliliters. And we already have our unit over here, 500 milliliters, and we know that we are solving for grams, so that's going to be X, and we want to make sure our units match up, and yes they do. So now we can solve for X. We're going to multiply this side by 500. That's going to cancel out. We're going to do the same to this side. The milliliters are going to cancel out. We're going to take 500 divided by 200, and that's going to give us 2.5 grams. So it's setting the proportion up exactly the same way. It's just writing it differently as a ratio. So that looks a little bit different than what you're used to. But if you want to turn your books to page 151, we're going to go through some problem set questions together. Get ourselves acquainted at looking at prescription labels. If we look at number 1, how many milliliters of solution are needed to provide 50 milligrams of lidocaine? Okay, so it tells us exactly what we're looking for. We're looking for milliliters, so we know that that's going to be X, and it's in 50 milligrams of lidocaine. That's the desired dose. So let's take a look at our prescription label, and as you can see, it reads lidocaine HCl injection USP 1%, and then we see in parentheses 10 milligrams per milliliter. Even though it says 10 milligrams per milliliter, we want to make sure we're lining up our units of measure properly. And if you look underneath, it says that there's a 10 ml vial. That's just extraneous information. Don't let that confuse you. That's not something you need to worry about. You're worried about the strength on the bottle. So now we can solve for X. Cancel this side out. The milligrams are going to cancel. 50 divided by 10, and X equals 5 milliliters. Okay, let's look at number 2. How many milliliters of solution are needed to provide 350 milligrams of acyclovir? So it says how many milliliters. We know that that's going to be X. Our desired dose is 350 milligrams. So let's take a look at the prescription label. Acyclovir for injection, and it's equivalent to 500 milligrams. And we're actually going to have to search a little bit. If you tilt it to the side, it says preparation of solution, inject 10 milliliters. So on some of these labels, you really do have to search to find out exactly the information that you're looking for. And our units of measure line up so we can solve for X. And X is going to equal 7 ml. Okay, let's do one more together on this page and then we will flip to solving for the drug. How many milliliters of solution are needed to provide 80 milligrams of furosemide? Okay, so again, we know we're solving for volume. We want to know how many milliliters. And our desired dose is 80 milligrams. Now we need to turn to the prescription label. And it reads furosemide injection 100 milligrams per 10 ml. And then if you look in parentheses right underneath it, it says 10 milligrams per ml. Either of these are right. You can use either one. In my case, I'm going to use the 1 ml per 10 milligrams. Either of these will give you the same answer, so it doesn't matter which one you use. And 80 divided by 10, X is going to equal 8 ml. Okay, so it really just comes down to being very thorough about reading the prescription label. Sometimes you're going to have to search a little bit, but the answers are all right there. So let's flip our page. Let's go to number 11. These are going to be basically the same, but instead of finding volume or milliliters, we're going to be looking for quantity of drug. Number 11, how many milligrams of ketorolac are contained in 0.5 ml? So instead of using X as milliliters, we're going to be solving for milligrams. The desired dose, 0.5 ml. So we look at our prescription label, and it says ketorolac injection 15 milligrams per milliliter. So 15 milligrams, we're going to put the milligrams on top because our variable is milligrams, and that's on top. We always want to make sure that they match up. So we're just going to solve for X. These two cancel out. Multiply by that, that's 7.5 divided by 1. So X is going to equal 7.5 milligrams. So same thing, but instead of looking for volume, we're looking for strength of drug.